that's it. Okay, we will be practicing a lot of questions like this, and then I will activate the assessment. Today we have not activated the assessment. In the next class we will do that. And yeah, Aisha, don't worry, after just completing this concept, the chapter, we will be starting the trigonometry only, and I will try completing it as soon as possible. Okay. Okay, everyone, I am keeping it this much. Let's continue the same in the next class. Today, no assessment. Homework we will send. You have to do the homework. Okay?
Yes, ma'am.
Okay. So yeah, take care of yourself. Thank you, everyone. Bye.
Thank you, ma'am. Take care.
Yeah, thank you. Take care, everyone. Okay, Alina and Naufal, please give me 2 minutes. I'm starting. Okay. Yes, Alina, Ali, and Naufal. Noah, your class is over, right? Have you checked timing, Noah? Okay. So we were discussing relations and functions. Just a moment. Let me open the book. Yeah, before that, I want to discuss the question which were there in the test. Okay. So there was a test from sets chapter. Ali has already given the test. Alina, have you given test? Yes, Alina. Can you hear me? Can you hear me?
Yes.
Okay. Just a moment. Let me take the question which was there in test from the sets chapter. Okay. So the first question is, by using Venn diagram, to represent the complement of A union B. The complement of A union B. Okay. So basically, when we have to make the Venn diagram, how we start drawing the Venn diagram? First, we draw a rectangular box to represent our universal set. Then we make one circle, another circle. We say that first circle is A, the next circle is B. Now, can you tell me, Alina and Naufal? Okay, Ali, you don't have to say. Can you tell me what is A union B complement? Which reason shall I shade over here that will represent A union B complement of that?
Whole box shaded except A and B.
Can you please repeat?
The whole box shaded except the circle A and B.
Wait, your voice is very low. Now, can you tell me?
The whole box shaded except the circle A and B.
Okay, the whole box except the circle, right? Is it so, Alina? He said the whole box except the circle. Is it so? Yes, Alina, are you there? Ali, is it so? Ali. The whole box we have to set except the circle. Is it so? That is A union B's complement. Yes or no?
Yeah.
That's what Naufal said. But Alina and Ali, I am waiting for your response. What you are thinking? Any idea? See, A union B means what? A union B means what? Union of two sets means A also, B also, and whatever is common, that also. That's called union. Okay? And if we have to shade the complement of that, that means from universal set, we will subtract A union B. That's called complement of A union B. That means everything except A union B. That is the meaning of this complement. Okay, a dash on the head is representing the complement. We can also represent as C. Okay, so that's called complement of A union B. And the meaning of complement of A union B means everything we will shade from the universal set, everything we will shade except the except A union B. What is A union B? A union B is this. So that's why he said correctly, perfectly, that we will be shading everything except this two circle, and that's called the complement of A union B. Am I making sense to both of you? Alina and Ali? Are you getting it?
Yes,
Ali,
ma'am.
are you there? Is it clear now?
Yes, ma'am.
Okay. Now there was a set which was represented in roster form like this. The element of set 1 by 2, element of set 2 by 3, element of set 3 by 4, element of set was 4 by 5, and element of set was 5 by 6, 6 by 7. Like that we were having the elements of the set. Now we have to represent the set which is given in the roster form in set builder form. So what can be written for that? Naufal?
Yeah.
Yes, it is given in set builder form. It is given in roster form. We have to write it in set builder form.
X is
Okay. So basically it's set of all x such that x equals to what? Check it.
fraction number.
Just fraction number. Fraction number can be anything. It can be 8 by 9. It can be 5 by 12. So the pattern, are you noticing the pattern? Pattern we have to identify. Whenever we are writing a given set from set builder form, again I'm saying set builder, it is given in roster form. Whenever we are writing from roster form to set builder form, we will first notice the pattern over here. Okay, how exactly the pattern is going on. So 1 by 2 is there, then 2 by 3, then 3 by 4, then 4 by 5. So whatever number is written in the numerators part, can you see in denominator part, the numerators plus 1. Okay, whatever number is there in the numerator, the denominator is numerator plus 1. Are you understanding the pattern? Whatever is there in the numerator, the denominator is becoming numerator plus 1, its own numerator plus 1. Okay, every time its own numerator plus 1. Okay, yeah, we can see this pattern that every time whatever number is sitting in the numerator, okay, that plus 1 is there in the denominator, and that is how we are getting the, that is how we are having the fractions over here. So can we write it as x equals to, in numerator there is a term, let's say n is there, so in denominator every time 1 is getting added to that. Okay, what is n? N is the, can you see the numerator is the 1, 2, 3, 4, 5, 6. It's a natural number. In the numerator, can you see it's a natural numbers? N is what? In the numerator, what is there? Natural numbers are there. Natural number starts from, can you tell me, Naufal, what is the natural number?
1, 2, 3, 4, 5.
All the counting numbers which starts from 1 are called natural number. So n by n plus 1, that means in numerator 1 we can take, then 2 we can take, then 3 we can take, then 4 we can take, then 5, and then 6. After 6 we don't have to go ahead. So we will say where n is natural number, but till which natural number? 6.
1 to
So
6.
can we, yes, so we can say natural number less than 7. N is natural number less than 7. N is less than 7. Be careful in numerator, whatever we are going to write, n, that is natural number. So whoever will read this statement, they will understand. Okay, we are going to make a set x where x is n by n plus 1. Now the question, the person will start thinking, what should be n? So here it is clearly mentioned that n is a natural number. So the person will start taking the first natural number, that is 1. Okay, then the person will take the next natural number, that is 2. Then the next natural number, that is 3. Then the next natural number, that is 4. Then the next natural number, that is 5. And the next natural number, that is 6. He will start, like the person will start taking 7, but realize that natural number less than 7 we have to take. That means at 6 we have to stop. So your statement must be that clear that just by reading your statement in set builder form, whatever you have written, just by reading it, me, your friend, any of your other teacher, everyone is making the same set. Everyone is writing the same elements in the set. It has to be that clear. That's why the definition of set says set is not just the collection. Set is the well-defined collection, well-defined. You have to define it very well. Can you see we have defined it well? Getting it? Yes, Ali. Is it making sense now? Ali.
Yes, ma'am.
This is how we have to write it. First, we will note down the pattern. If in your book, if you have practiced this question and in your exam, suppose different fractions are there. Suppose in your exam, this type of pattern is there. 1/3. Okay. Then 2/6. Wait. If this type of fraction is there, are you able to identify the pattern? Are you? Or you are going to write the same answer which we have written previously? No. Here it is n/n. Yes, perfect. Here it is n/n plus 2. So you have to check it carefully. You have practiced something and something else came in the exam. So you have to be very careful. Read the question carefully. See how exactly the pattern is going on, and then you will define in set builder form that whatever will be the this is how the pattern is going on. In numerator, natural numbers are there, or maybe odd numbers are there, or maybe prime numbers are there. This is how you have to define it. It's all about reading the pattern. Okay, carefully. Now the next question was, set A was given over there. This one you will be able to do. Set A was given over there. 3, 6, 9, 12, 15, 18, 21. Set B was given over there. 9, 8, 12, 16, 20. If the question is find B minus A, then find B intersection A, then find A union B. Let's do it quickly because this one is not that tricky, right? B minus A. What will be B minus A? What will be B minus A?
8, 16, 20.
Can you repeat it one more time? 16 you said?
8,
8, 16. What else?
20.
20. Is it correct? Naufal, you said, right? Or Ali, you said?
That's it.
Okay, Naufal said. Yes, Ali, is it correct? Is it? Check it.
Yes, ma'am.
Alina, are you there? 8, 16, 20. Yes. Let's check it. B minus A means everything whatever is in B, but not in E. Every element which is there in B, which is there in the set B, but not in set A. So 9, we were about to write 9 over here, but 9 is in A. We have to cross it. Okay. Now 8. Is there any 8 in A? No, 8 we can take. 12. 12, we were about to write 12 over here. Then we realized 12 is already there in A. So we are writing all the element which is there in B, but not in A. So 12, we have to cancel it. Yes, it is correct. B intersection A will be? B intersection A will be? 9, 12. That's it? Yeah, that's it. Okay, intersection is only the common element. Union will be? A union B will be?
3, 6, 9, 8, 12, 15, 16, 18, 20, 21.
Yeah, everything. Okay, the common element we are writing only once and remaining element also. Now the next one was subset of A. Previous class we were talking about the subset, no? There is a set A having an element just AB. Tell me what will be the subset of this A. How many elements will be there in the subset?
4.
Okay, we will be able to generate 4 subsets. We will be able to generate 4 subsets. Okay, total 4 subsets we will be able to generate, which will be a subset of set A. Okay, first one will be
5.
5. Ali, next one will be a set containing an element.
A.
Perfect. Yes, Naufal, next one will be
B.
and the last one will be
A. B.
this is how we will make the list of all the sets which will be subset of set A. Okay, next one. Okay, next one already you have done. I am keeping it this much. These questions were there in our class in the previous test. Yeah, and that's what I wanted to discuss over here. Yes, most of the solution is right, Ali. Few I wanted to discuss, that is the graphical part, and yeah, just that. Let's continue with our topic, that is relations and function. Just a moment. Alina, can you hear me? If not, please check your connectivity. Okay, because Naufal and Ali can already hear me and they are responding over here also. Just a moment, let me start with relation and function. Have you solved the first exercise by yourself? Have you have you faced any difficulty while solving any of the question from there? Alina, you are unable to hear me. Why? I can hear everyone and they can hear me also. Please check if any setting issue or what is there. Yes, Naufal and Ali. Have you solved exercise, this like first exercise? Cartesian product we were discussing. Have you solved the first exercise? Naufal? Yes, Naufal. Have you?
No, I didn't do it yet.
Okay. Once you do it, let me know if you are having any confusion in any of the question. Ali? Have you done?
Yes, ma'am.
Is there any confusion in any question, any concept?
No.
Let's continue with the next concept, that is relation. Alina, please check. Please check what is what exactly is the issue. Is there any setting issue in the Zoom? Is there any connectivity issue, the network issue, or what? Okay. Or let me inform our operation team if any issue is there at our end or what, that also we will check. Just a moment, Alina. Please let me write over here. Because whatever I am saying, you are not hearing that. So it is not making sense that I will keep on repeating. Okay, let's start with the concept of relations. Okay. Cartesian product is already clear to us. In Cartesian product, we understood that we are writing element of the set is an ordered pair. Ordered pair, and we were writing all possible ordered pair. Two sets were given, and from those two given set, we were listing down all the possible ordered pair. That was called Cartesian product. Now here relations we will see. Relation means it's just like the relation between two person, relation between any pair. So yeah, here we are talking about the relation, but here relation between two sets. Here we will be having relation between two sets. So it is linked to the concept of Cartesian product. Let me take one example. I am explaining. Suppose there is a set A having elements 1, 2, 3. Okay. And if we will be finding the Cartesian product, that is A cross A. Can you tell me what will be the elements? What will be ordered pair? Yes, Naufal and Ali.
1, 2, 1, 3.
Then
2, 3.
just that. Are we done? Ali, if we have to find the Cartesian product between A and A, then what will be the Cartesian product?
1, 1.
Then
2, 2.
2, 2. 3, 3.
3.
then make the diagram, mapping diagram, make it 1, 2, 3, A. Again A, 1, 2, 3. Tell me the Cartesian product now properly. Yes, Alina, can you hear me? Are you there now?
Yes, ma'am, I can hear you.
Okay. So yeah, previously I was calling your name. I was without realizing that you are not hearing me. I just kept on telling. It's okay. We were discussing question from the class test portion. Okay, now only we have started the relation. I have given one set A that is having an element 1, 2, 3. Now my question is, what will be the Cartesian product between A and A? Tell me. What will be A cross A? 1 with 1 is fine. 1 with 2 is also okay. Okay. 1 with 3 is also be there. 1 with 1, 1 with 2, 1 with 3. Now tell me the next one.
2 with 1, 2 with 2, 2 with 3.
2 with 2, 2 with 3. Tell me the next one.
3
3 with
with
1,
1,
3 with
3
2,
with
3
2,
with 3.
3 with 3.
Perfect. This is how we will be finding the Cartesian product between A and A. Okay, this question is there in the exercise. So if you have solved the exercise, you will be able to understand. If the question is again same, A cross A cross A, tell me what will be the answer. Okay, so many elements will be there. Suppose I am redefining our A. Suppose I am giving set A as a 0, 1. Okay, now tell me what will be A cross A cross A.
0,
1, 1,
0,
1.
0.
1 by 1. Alina, you tell me, then Naufal, I am coming to. Yes, Alina, tell me.
0, 0, 0.
Then
0, 0, 1.
then
0, 1, 1.
then
0, 1, 0.
then
1, 0, 0.
then
1, 1, 0.
then
1, 1, 1.
yes, Naufal, tell me. If a set is having just 0, 1, what will be A cross A cross? Yes,
0,
Naufal.
0, 0. 0, 0, 1. 0, 1, 0. 1, 0, 0. 1, 1, 1. 1, 1, 0. 1, 0, 1. 0, 1, 1.
Okay. Wait. Just a moment. Yes. Alina, have you left anything? Have you? Check it.
1, 0, 1.
Yeah. Total 8 element has to be there because 2 element here, 2 element here, 2 element here. So total 8 elements, 8 triplets. Okay. Ordered triplets has to be there. Okay. Ordered pair here we are not having. Ordered triplet we are having. And 8 ordered triplet has to be there. Ali, are you getting it? How exactly we will do? No. How exactly we will do when we are having A is equals to 0, 1. We will first find the Cartesian product between A and E. And that will be, we will be listing down all the element A and A. So it will be 0 with 0. It will be 0 with 1. It will be 1 with 0. And it will be 1 with 1. Now, in this Cartesian product, again we will multiply. Again we will just find the product of A. So that means A is 0, 1. So in each and every one, we will be taking 0, then 1, then 0, then 1, then 0, then 1, like that we'll be taking. So first one is 0, 0, that will become 0, 0, 0. First one is 0, 0, that we are taking with this one, and that we will be taking with this one. This is how we have to proceed, and we will be getting the Cartesian product of AAA. Okay. Now the question was, what will be the Cartesian product of this? If the set A is there and 1, 2, 3, these three elements are there in our set, then the Cartesian product between A and A is this. Now we have discussed the concept of Cartesian product. Here we are discussing the concept of relation. Now relation means there will be a certain condition that these are all the possibility of ordered pair, but we cannot pick all ordered pair. We will give a condition. We will define a relation. What relation? Relation, if we are writing it in set builder form, this is how we can define. A relation is there which consists of all the ordered pair xy, okay, having all ordered pair xy, such that the way we were writing our set in set builder form, here we are trying to write the relation in set builder form. Okay, from where are we writing? I am trying to generate a question. Let me write it. Okay, here this is the Cartesian product. Let me write this mapping diagram. I am writing the Cartesian product over here so that we will be able to see what exactly is there in our Cartesian product, and then we will focus on our relation. What exactly the relation is talking about. A condition will be applied, and that's called relation. That means a relation will be given between two sets. So A cross A, we were having element 1 with 1, we were having 1 with 2, and then 1 with 3. Similarly, we were having 2 with 1, 2 with 2, 2 with 3. Similarly, we were having 3 with 1, 3 with 2, and 3 with 3. This is what we were having when we have listed down the Cartesian product. All the possible ordered pair. Now the relation is defined as we have to take only those ordered pair where x is smaller than y. So from this roster form, from this all the ordered pair, we are bound to take only those ordered pair where x is less than y, where x and y belongs to A only. Okay, x is the first element, y is the second element. So let's make the relation. The relation is such a set which will be having only those ordered pair. Let me clear it. It is clearly written over here that it will only have those ordered pair where x is smaller than y. Okay, where x is smaller than y. So tell me which ordered pair can be taken over here from the above set, from the above Cartesian product, which ordered pair we can take where x is smaller than y. That means the first element is smaller than the second element. Which one can be taken? Alina, Naufal, and Ali. From the above Cartesian product of A cross A, which ordered pair we can pick so that the first element is smaller than the second element? Are you getting it?
2, 1 is to 3.
1 with 2 we can take. This one. 1 with 3 we can take. Perfect.
2, 3.
Then 2 with 3 we can take. Then anything else? Anything else can we take where the first element is smaller than second element? No. Okay, for the first one it is equals to We can see other are greater or maybe equal to. So these three elements will be there, where the first element, okay, in our ordered pair, the first one is smaller than the second one. If this condition is applied, if this relation is given, if this condition is given, then we are not allowed to take all the possible ordered pair. From all the possible ordered pair, we only be picking according to the given relation. So that's why we say that relation is the subset of Cartesian product. In Cartesian product, we write all the possible ordered pair. But when we are having a relation, we have to be careful the way it is mentioned in our relation that x has to be less than y. We have taken accordingly x less than y, first element less than the second one, and that's how we have picked only 3 ordered pair. How many ordered pair we were having? 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 ordered pair we were having. And how many we have taken? Only 3 were fulfilling the criteria which was given. So what is relation? Relation is just a given condition. The Cartesian product which you have learned previously, in that Cartesian product, now we will paste a condition. And you have to be careful. You have to be careful that you are fulfilling your ordered pair must fulfill the given condition. That's called relation. Because on day one, I was talking about in mathematics, x is smaller than y. It's a relation between x and y. Okay, x greater than y. It's a relation between x and y. So these are called, if x plus 2 is equals to 20y, it's a relation between x and y. Okay. So here we are talking about the relation between two sets. Relation between two sets where the element of first set has to be smaller than element of second set. Getting my point? Getting it?
Yes.
Yes,
Now,
ma'am.
the other relation, we have to understand what exactly the relation is talking about or what exactly the condition is talking about. The other relation, suppose we are having just a moment. If a set is given as 1, 2, 3, 5. Okay. B, another set is there, which is the element of this set is 4, 6, 9. Now we have to find a relation is defined. That means always a condition will be there. Here we are not finding the Cartesian product so that we can take 1 with 4, 1 with 6, 1 with 9. Then 2 with 4, 2 with 6, 2 with 9. 3 with 4, 3 with 6, 3 with 9. 5 with 4, 5 with, that's called Cartesian product. The relation will be the subset of that. If you have understood, then can you see here? This relation is the subset of this A cross A. It is subset. The element 1, 2 is there in the relation. 1, 2. This element belongs to R. And the same 1, 2 belongs to A cross A. Okay. Apart from that, we can also see 1, 3. The element, the second ordered pair belongs to R and it also belongs to A cross A. 2, 3 belongs to R and 2, 3 also belongs to A cross A. So can we say R is the subset of A cross A? Can we? R is subset of A cross A. Can we say that over here?
Yeah.
Yes, ma'am.
Okay. So that's why we say that each and every concept is linked with each other. Okay, this terminology must be clear to you. Let's continue with our question. A and B I have written over there. R is given as R is the set of all ordered pair XY. Okay, such that the difference of X and Y is odd. Here it is clearly mentioned X is element of set A and y is element of set B. So relation between the first set, the second set, element of the first set to the element of second set. Now, every time we don't have to write the Cartesian product, but here for this question, just for our understanding, since we have started the concept, we will be writing the Cartesian product. Okay, but when we will learn this concept very well, then we are not going to write the Cartesian product every time. This is just for understanding. So let's note it. Let's write the Cartesian product A cross B. Tell me, Ali, what will be there? 1 with
1 with
Ali.
4, 1,
Then-
6, 1, 9, 2, 4, 2, 6, 2, 9, 3, 4, 3, 6, 3, 9, 5, 4, 5, 6, and 5, 9.
This is the Cartesian product. But we cannot take all the ordered pair. We can only take those ordered pair where the difference of x and y is odd number. Difference of x and y is odd number. Any way you can find the difference. If it is an odd number, you can subtract only larger number minus a smaller number. Okay? X and y means you can also find x minus y or y minus x. That means larger one minus a smaller one. If your answer is the odd number, then that ordered pair you can take it in the relation. From this, all the ordered pair, whatever is fulfilling the criteria, that like the difference between the two is odd number, then we can take that ordered pair in our relation. So let's write here. The relation is given in set builder form. Check it carefully. It is given in set builder form. Set of all ordered pair. The difference of x and y is odd number. Okay. We will be writing it in roster form because roster form will make it more clear. Okay. Let's write it in roster form. Can you tell me which ordered pair is fulfilling the criteria that difference between two is odd number? So the first one. Let's start from the first one. 4 minus 1. Is it odd number?
Odd.
Yes,
We can
ma'am.
take that. Okay.
1,
Next.
6.
1, 6. 1, 9. Can we take that?
No. No.
We will not take that. 2, 4. Can we take that?
No.
No,
2, 6. Can we take that?
No.
no,
2, 9. Can we take that?
yes,
Yeah.
We can take that.
3,
3,
4.
4. Can we take that?
Yeah.
no, yes, yes,
3, we can take. Okay. 3 minus 4. 4
3,
minus 3.
6.
3, 6. Yes, we can take that.
yes.
3, 9.
5,
Can we?
No. No.
5, 4,
5, 4.
5,
5,
6. Can we take
6.
5, 9? Can we?
No.
No. Can you see? We have listed down all the ordered pair which is fulfilling this relation. All the ordered pair which is fulfilling this relation. All the ordered pair which is fulfilling this condition. We have noted it down successfully. Okay. And that's called relation. This is how every time a condition will be pasted. And we have to be careful. Accordingly, we will be taking the ordered pair. Here we are listing down the Cartesian product also. But when we will be pro with it, we will get the concept very well. We don't have to write the Cartesian product, but here we are writing the Cartesian product so that it will be more clear to us that relation is the subset. Relation is the subset of Cartesian product. So in mathematics, when you will read any definition or any statement, you will feel like it's very confusing. So in lower class, when a student read the definition of rational number, every number which is in the form of p by q is a rational number where p and q are integer and q will not be 0. That time it was very confusing to our students. But when we will decode it, that we are just having a fractional number where denominator will not be 0. Every fractional number is called rational number. That way it became so simple. Similarly here, when you will read the definition in your book, so relation is a subset of the Cartesian product. This is what you will find in the definition. But exactly you can see it over here that we are taking the element from the Cartesian product only. But all the element we are not allowed to choose due to the given condition, due to the given relation. Okay. Now one more concept is there. Every first element, 1, 2, 3, 4, like this 5, these are called the domain. These are called the domain of the given relation. Okay, domain. Domain means all first element from our relations ordered pair, not the Cartesian product. From our relations, whatever we have listed down in roster form, we will check what are the first element. All the first element are domain of the relation. Okay, and all the second element, 4, 6, 9, 4, again 6, 6, these are called the range. These are called the range of the given relation. Okay.
Maybe also called codomain.
And codomain will be the set of all second element. Second element, the set of all second element, 4, 6, 9, everything all together, it's called codomain. So your set can be like this. Your mapping diagram can be like this. Suppose we are having the first set is, let's say, X, and the next set is 1. I am writing it in the form of mapping diagram. Okay, 1 is there, 2 is there, 3 is there, 4 is there. These are the only 4 elements. In our set X, we are having only 4 elements, 1, 2, 3, 4. In the set Y, I am writing it. I'm trying to increase it because I want to include more numbers. Like that, till 17 numbers are sitting over there. Okay, 1, 2, 3, 4, 5, 6. How many elements are there? Till 17, all the numbers are. Now it is going like that. 1 is going to 1, 2 is going to 4, 3 is going to 9, and 4 is going to 16. Okay. If we have to write by using the mapping diagram, just by looking at the mapping diagram, if we have to define the relation in set builder form, can you tell me what shall we write? Who will tell me? See the pattern, how the numbers are going, and tell me the relation. Tell me.
Ma'am, x such that x is equal to n square, where n is a natural number.
Yeah, set of all ordered. You said it correctly. You identified it correctly. Now let's write it properly. R is the set of all ordered pair XY. Here we are not having a single element. Okay, ordered pair we are having. The element of this set is an ordered pair. Okay, set of all ordered pair XY such that can we write y is the square of x? Y is equals to x square. Can we write?
Yes, ma'am.
Okay. What is x? What is y? Where x belongs to the first set and y belongs to the second set. This is how properly a well-defined set we have written. Are you getting it? Yes, Ali, you identified it correctly. Getting it, Naufal?
Yeah.
Okay, so by looking at the mapping diagram, we are able to write the relation in set builder form. Okay, now we were talking about the domain, codomain, and range. Now here domain will be set of all inputs. What are the input? 1 is there, the first element, set of all first element. 1 is there, 2 is also
Two.
there, 3 is also there, and 4. These are the domain. Okay. Now codomain and range. Can you tell me what is range? Yes, Naufal.
1, 4, 9, 16.
1, 4, 9, 16. 1, 4, 9, 16. These are the range set of all outputs. Output is only 1, only 4, only 9, and only 16. That's called range. So if I am saying that set of all second element domain is 1, again 1, again 2. So you know that in this, when we are writing a set, we don't have to do the repetition. 1 is there, 2 is there, 3 is there, and then 5 is there. These are the domain. Range is all the output, all the second element. Okay, second element is 4, 6, 9. Again 4 is there, again 6 is there, 4, 6. So basically 4, 6, 9. Okay, these are the range. Okay, all the first element is the domain, all the second element is the range. Or we can also call it all the inputs. Input, when we are giving the input 1, the output is coming out as a, in our second one, when we are giving the input 1, when we are giving the input 1, the output we are getting 1. When we are giving input 2, the output we are getting as a 4. When we are giving the input 3, the output we are getting as 9. When we are giving the input 4, the output we are getting 16. So basically, range is the set of all output, domain is the set of all input, and codomain. What is codomain, Naufal?
1 to 17.
1, 2, 3, everything till 17. Codomain, Ali, Alina, Naufal. Codomain means, yes, Naufal, it's perfect. Codomain means everything. Everything, whatever is there in the second set, that's called codomain. Everything, all the element, whatever is sitting in the second element. See, the second set is Y element, I said. The second set is Y. So all the element of the second set, that's called codomain. Completely. It can be output, it cannot be output, doesn't matter. So domain means all the inputs, all the first element. Range means all the second element, or we call it output also. And codomain means everything from the second set, all element from the second set. It can be output, it cannot be output, doesn't matter. Everything is called codomain. Am I making sense to all of you?
Yes, ma'am.
Okay, this is how we will be identifying. Suppose a relation is given like this. A set P is there, a set Q is there. Mapping diagram, I am drawing it. You have to write the relation. Element 9, element 4, 25. Here we are having 5. Here we are having 3. 1, -2, -3, -5. Let me make the diagram connected. 9 is going to 3. And 9 is also going to -3. Similarly, 4 is going to, 2. And 4 is also going to -2. Similarly, 25 is going to 5. And 25 is also going to -5. Now tell me, relation R, if you have to define the relation the way we did just now, tell me how you will define. Identify the pattern and let me know.
Exclusive x is the square of y.
Wait, let me write. Set of all ordered pair xy such that
X is the square of
x is okay equals to also we can write. Can we write it like this? And what is y? Now we have to define what is x, what is y. Just a second. Yeah, we can write that. Now we can write set P is 9, 4, 25. And we can also write set Q is these are the element of set Q, that is 5, 3, 2, 1, minus 2, minus 3, minus 5. Okay, where x, this x belongs to the first set and
second.
y belongs to the second set. Okay, and this is called well defined set. Okay, the relation which we have written, that relation is also a set, and this is how we have written it in set builder form. Are you getting it, Ali?
Yes, ma'am.
X is just the square of y. What is now? Can you tell me what is domain?
9, 4, 25.
Right? What is range?
3 minus 3, 2 minus 2, 5 minus 4.
3 minus 3, 2 minus 2, 5 minus 5. Perfect. Here and there it's completely fine. In set chapter you already have seen. Now codomain.
5, 2 minus 5.
5.
3, 2, 1 minus 2 minus 3.
Everything from Q, right?
Yeah.
The set Q is codomain. Okay, yeah, set Q we will copy paste over here. Whatever is there in the set Q, everything we will write over here. That is our codomain. Getting it, Ali?
Yes, ma'am.
Let's solve few more questions. A set A is given as 1, 2, 3, 4, 5, 6. Okay. A relation is defined. R is given as set of all ordered pair xy such that y is equals to x plus 1. Okay, a relation is defined from A to A. A relation R is defined from A to A. So the Cartesian product is A cross A. From there we have taken the ordered pair. Which ordered pair we have taken? All those ordered pair where y is equals to x plus 1. Now write this relation in, right? Here it is given in set builder form. Here it is given in set builder form. Write it in roster form. R in roster form. Tell me what will be the ordered pair which will be there in R. Now we will not write the Cartesian product. A with A, that means 1 with 1, 1 with 2, 1 with 3, 1 with 4, 1 with 5, 1 with 6. We are not going to write all the possible ordered pair in the Cartesian product. As I said to you, that yes, it is coming from the Cartesian product. This relation, whatever we will be having over here, it will come from the Cartesian product only. But every time we will not be listing the Cartesian product. We will be doing it directly. Okay. Tell me what ordered pair will be there in our relation.
1, 2, 2, 3, 3, 4, 5, 4, 5, 5, 6.
1, 2, then 2, 3, then
4, 5. 4, 5, 5, 6.
anything else? Are we leaving anything else? Yes, Ali. Only these elements, these ordered pair will be there.
3, 4.
Anything else?
Ma'am, 6, 7.
Can we take 6, 7? Because it is A cross A. So A with A only we have to do. If you will list down only the Cartesian product of A with A is having element 1, 2, 3, 4, 5, 6. If you will list down the Cartesian product only, will there be 6, 7 also? Will there be 6,
No,
7?
ma'am.
So we cannot take. Okay, because whatever is will be there in our relation, that will come from the Cartesian product. Okay, so A with A means whatever element is there in A, and then the other set is also A. So our first and second element must be from A only. From A only, whatever is visible over here. And then only we have to stop ourselves. Even if we will try writing few more ordered pair, but we have to stop ourselves that we are not allowed. We have to take the first element, the ordered pair, the first from A, second also from A only. Okay, so the condition is y is equals to x plus 1. Directly we are trying to write. Now we will not write the Cartesian product directly. So x plus y will be, the second element will be whatever is the first element, that plus 1. So we can see the set A carefully. See the set A. We can take x as a, x as a 1. We can take x as a 2. We can take x as a 3. We can take x as a 4. We can take x as a 5. That is allowed. But y will be every time x plus 1. So it became 1 with the y will be whatever is there as a first element, that plus 1. Y will be whatever is there as a first element, that plus 1. Y will be whatever is there as a first element, that plus 1. Y will be whatever is there as a first element, that plus 1. And y will be whatever is there as a first element, that plus 1. Now x as a 6 we are trying to take, but next element will come, the first plus 1, that is 7. But 7 is not there in, so we are not allowed to take that. Getting my point? Yes, Naufal, it is perfect. Getting it?
Yeah.
Yes,
Yes,
Ali, getting it. This is how we will write. Let's do a few more questions. A, or set A is given as 1, 2, 3, 4, 14. Okay. Previously, let's every time write down our domain, our range, and our codomain. Tell me what is domain. Ali, what is domain?
ma'am. 1, 2, 3, 4, 5,
That's it.
6.
6 also. Naufal, what is domain?
Yeah. Plus 6.
Yes.
1 to 6.
Is 1, 2, 3, 4, 5, 6 also will be there or not? That is the main question.
It was.
It will be?
Yeah.
It will not be
Ma'am,
there.
it will
Not-
be there.
Alina, you are there. You can hear me? From that time, I was thinking that you are not even there. It will be there, Alina?
Yes, ma'am.
Okay. Yes, Naufal, what you said?
It's not there because you're taking from R.
Yes. We are taking from R set of all input. Input. 1 is generating the output 2. 2 is generating the output 3. 3 is generating the output 4. 4 is generating the output 5. 5 is generating the output 6. 6, when we are giving the input, it is not generating the output from the given set A. So that we cannot take in the domain. The domain is the set of all inputs. Set of all possible first element from R. From R, we are going to take all the first element, not from our set. Okay, not from the set A. From R, we will be saying all the first element. Check it. It is 1, it is 2, it is 3, it is 4, it is 5. Just that. That's our domain. Getting it?
Yes, ma'am.
Alina? Are you getting it, Alina?
Yes, ma'am.
What is range?
2, 3, 5, 4,
2, 3, 4, 5, 6.
5, 6.
Perfect. And what is codomain?
Ma'am, 1 to 6.
1, 2, 6. 1, 2, 3, 4, 5, 6. Getting it, Ali?
Yes, ma'am.
Domain means all the possible input. All the possible input. Ranges all outputs. Codomain means all element from the second set. That's called codomain. Everything. Okay. Or you can also say domain is all the first element from our relation, the ordered pair which we have written in the relation. From there, all the first element. Okay. Range is the all the second element from the relation R. Let's do a few more questions to make it more clear. We are having, this is what we are having. Relation R is defined. Relation is defined from A to A. From A to A means what? From A to A means A cross A, the Cartesian product A cross A. That's called A to A. That means our first set is also A and second set is also same A. That's called A to A. Okay. Now R is given as set of all ordered pair xy such that 3x minus y is equals to 0. Where xy obviously belongs to A only because both are same set A. So x is also from A, y is also from A. Okay. Now we have to write it. It is given over there in, here it is given in set builder form or roster form. Yes. Here it is given in set builder
Ma'am,
form.
Set builder.
It is
builder
given
form.
in set builder form. We have to write it in roster form. Let's write it. Can you tell me what order here will be there? 3x minus y is equals to 0. R will be can we write it as a 3x is equals to y? Just a little bit of simplification in this equation. Are we allowed? Yes, we are allowed.
Yes, ma'am.
3x minus y is equals to 0 means what? We can do the customization. We are pro at it. We have solved so many tricky equations. So this is very simple one. We can just shift y on the other side and it became 3x is equals to y. Now it became very simple. Okay. Y,
1,
x,
comma, 3.
X, whatever we want to take, we can take it. But y will be 3 times of that. Y will be 1, comma. Then 2, comma.
6,
6,
Then 3, comma.
3, 9.
9,
Then 4, comma.
12,
4, comma.
12,
12,
Then 5, comma.
15,
15,
Then 6, comma.
18.
18.
No, it's not that.
Are we allowed to take this?
No,
Till 15? Is there
No.
18?
No.
no.
So we cannot take that. So we also have to be careful while writing this ordered pair. Okay, because both the element clearly written in the set builder form that x is also from A and y is also from A. X has to be from A and y has to be from A. It is clearly foundation is given, so we cannot break that. And these are only the ordered pair which will be there in our relation. Again, from where it came? In Cartesian product, all the possible ordered pair will be there. Here, few of them are there. That's why we say relation is the subset of Cartesian product. Now, if the question is what is domain, what is codomain, and what is range? Tell me. What is domain?
1,
1, 2,
3,
3,
4,
4,
Perfect. What is range?
3,
3,
6,
6,
9,
9, 12,
Perfect. What is codomain?
1 to 14.
Any confusion?
No, no.
Any confusion? Let me take one tricky one, so that now you can try solving the whole exercise again by yourself. Let me make it clear. Maths is all about practice. The more you are practicing, the more you will feel confident, the better you will solve question, the less you will get stuck while solving the question. So it's all about practice only. Okay, I have seen in my class one student is so bright and the other student is just, they like when I'm explaining, student is understanding the concept that much, and one is over smart. Okay, but when the other student is practicing a lot, that student will be always ahead of all the other students. It's all about practice. It's all about practice. So practice as much as possible. First solve the NCRT, then solve like whatever extra question you are getting from here and there. You are giving here test, give the test properly, see any extra question, any question is there which is quite tricky and you are not able to do. Why you are not able to do? You have understood the concept, so you should do. If you are not able to do, then here we will be discussing that what concept can be applied over there. This is how you have to prepare mathematics. Okay, every day you have to sit with the subject, 1 hour 2 hour you have to give that a proper time to this subject. It's not about just turning the page and getting the concept. It's not about that. Okay, other subject you can learn it that way, but don't do this with mathematics, because when you will start solving the question, you will get stuck. Okay, you think that you know, but when you will do it by yourself in test or exam, you will get stuck. So from now only make it a habit that you are practicing enough. These all the concept, again we will be talking about these all concept in class 12 when we will be talking about relation and functions chapter, and teacher will expect you to know everything. So that way only learn everything, so everything will get registered in your mind. Okay, because you have just started the session, so you are having time in your hand now. When the whole session will over, then I will repeat the same, like the same lecture I'll give you. That will not, maybe it will work or not work, but now it will work because now we have just started. Okay, so make it a habit. First exercise, do it. Second exercise today I will give. In our next class you are coming by doing both the exercises. Okay, okay.
Okay.
Okay, ma'am.
You will find that you are able to do all the questions from this exercise, right? The relation R is equals to, okay, one concept is there. Let's do this one, then we are coming to that. X cube such that X is prime number less than 10. We have to write it in roster form. Let's write it. R will be having element x cube is there, where x is what? X is what? Prime number. Prime number less than 10. Let's make the list of prime numbers less than 10. Can you tell me what will be the first prime number?
2,
2,
Next,
3,
3. Next,
5,
5,
7,
perfect. Next,
7, 9.
7,
9. 9 is a
7.
prime number.
11.
no,
No,
Less than 10. Alina. We
that's
are
it.
done, right? So first element x is a prime number less than 10. First 2 we can take. Then ordered pair says the next will be x cube. So it will be 8, right? Right? 3 and then
27,
27,
5 and then
120,
125,
7 and then
37, 340.
340. Okay. So yeah, these are the this one is our relation in roster form. Now the next concept is suppose A is 1, 2, 3. B is 5, 6. Number of element in A cross B will be 6. Number of element in A into number of element in B. That means 3 into 2, that is 6. Yeah, it will be 6. Now, again and again, we have seen it from the very beginning that relation is what? Relation is the subset of. Relation is the subset of Cartesian product. Relation is nothing but just the subset of this Cartesian product A cross B. Whatever, like in this Cartesian product, we are writing all the ordered pair, and in our relation, we are choosing few ordered pair according to the given condition. So how many relations we can make? Okay, how many relations we can make? Possible to generate. That means how many subset from this A cross B, how many instead of relation, how many subsets we are able to generate. A set which is having 6 element, a set which is having 6 element, how many subsets we will be able to make out of that? A set is having 6 element, 1, 2, 3, 4, 5, 6. How many subset you will be able to create out of that? 2 to the power
6.
6. Now I'm going to write one statement. Tell me whether it is making sense to you or not. In your book also you will find the same statement, that if number of element is A is B and number of element in set B is Q, then number of element in A cross B is PQ, which we know that now only we have seen that, and total number of relation it will generate to the power PQ. Is it making sense to you?
Yes, ma'am.
Yeah.
It is making sense because relation is subset of Cartesian product. Whatever number we have got in the set of Cartesian product, 2 to the power that many subsets, that many different set we will be able to create, and that many relations are possible to get. Getting it? Getting it?
Yes, ma'am.
If you are getting it, then tell me this question. Now we are done. The last question. Let A is equals to XYZ, B is equals to 1, 2. Find the number of relations from A to B. How many relations?